This is part 3 in a series of 6 videos about division by zero. We look at algebraic operations with hyper-complex numbers, and we'll also introduce a new type of number, the meta-complex numbers. In the previous video, we saw that hypercomplex numbers are numbers of the form a plus bi plus cz, where a, b, and c are real numbers, and I is a square root of -1 and z is 1 divided by 0. The sum of two hypercomplex numbers, h1 and h2, is obtained by adding the real parts, the imaginary parts, and the zero parts of both numbers separately. Let h1 be a1 plus b1i plus c1z, and h2 a2 plus b2i plus c2z. The sum of h1 and h2 is as follows. We will add a1 and a2 separately, b1 and b2 as a coefficient of I, and c1 and c2 as a coefficient of z. As you can see, this results in a new hypercomplex number with a real part a1 plus a2, an imaginary part b1 plus b2, and a zero part c1 and c2. Let's now multiply two hypercomplex numbers, h1 times h2. a1 plus b1i plus c1z times a2 plus b2i plus c2z equals a1 a2 plus a1 b2i plus a1 c2z plus b1 I a2 plus b1 b2i squared plus b1 I c2z plus c1z a2 plus c1z b2i plus c1z c2z. Notice the term b1 b2i squared. I squared is, as we know, equal to -1. So the expression can already be rewritten by replacing b1 b2i squared by minus b1 b2. If we rearrange all the terms, we get a1 a2 minus b1 b2, which is a real number, plus a1 b2 plus a2 b1i, which is an imaginary number, a1 c2 plus a2 c1, which is a zero number, and then b1 c2 plus b2 c1 iz plus c1 c2 z squared. So here we've got two rather strange terms, one with iz and one with z squared. Let's look at the z squared term first. What is z squared? Z squared, of course, is z times z. That is 1 divided by 0 times 1 divided by 0, which can be rewritten as 1 times 1 divided by 0 times 0. And this, of course, is 1 divided by 0, which is our initial z. So we know that z squared is equal to z. So we can write the term c1 c2 z squared as c1 c2 z and regroup it, put it under the zero number a1 c2 plus a2 c1 plus, in red, c1 c2 times z. And then there's this very strange term with iz. What is iz, or I times z? It is the square root of -1 times 1 divided by 0, or the square root of 1 divided by 0, which is neither an imaginary number nor a zero number, and of course not a real number. Iz is the unit of what we'll call the meta numbers. Iz is the meta number unit, and meta numbers are numbers of the form diz where d is a real number. This way we can further extend our number sets with a set of meta-complex numbers. Those are numbers m of the form a plus bi plus cz plus diz, where a, b, c, and d are real numbers. The set of all meta-complex numbers we will call M. Let's add the sets of meta-numbers and meta-complex numbers to our list of number sets from the previous video. The new sets of meta-numbers and meta-complex numbers are indicated in red. Why do I call the numbers with iz meta-numbers? Because they can no longer be represented in a three-dimensional space, so they go beyond meta, the possibility of representation in 3 dimensions. Let's have another look at the powers of z. We already saw that z squared equals z. In general, we can say now that z to the nth power will be equal to z for all positive and non-zero whole numbers. So how about negative powers of z? Z to the minus n. That is equal to 1 divided by z to the power n, which is 1 divided by z, or 0 divided by 1. And that is, of course, 0. Remember that a negative power of z is 0. So how about the 0th power of z? There is no consensus about the value of 0 to the 0th power. The most common values for 0 to the 0th are 1 or undefined, depending on how you calculate 0 to the 0th power. Similarly, the value of z to the 0th power also depends on how we calculate it. If we define 0 to the 0th as 1 divided by 0 to the 0th, this becomes 1 to the power 0 divided by 0 to the power 0, which is 1 divided by 1 if we take 0 to the power 0 to be 1. And of course, 1 divided by 1 equals 1. But if we calculate z to the power 0 as z to the power n minus n, then this becomes z to the power n divided by z to the power minus n. But as we know from what precedes, this equals z divided by 0, or z times 1 divided by 0. So that is z times z, or z squared, and that is, of course, z. Since z equals z squared, the square root of z equals the square root of z squared, and that, of course, is z. Generally, we can say that the nth root of z will be equal to z. So far, so good, but now let's consider the division of two meta-complex numbers. This becomes much more complicated, even when we consider the very easy case of real zero numbers of the form a plus cz. The division of two of those numbers has the form a1 plus c1z divided by a2 plus c2z. Now, unlike in the case of complex numbers, if we start to work out this division, we end up with a number that looks very complicated, and that doesn't make any real sense. So we'll conclude that the division of real zero numbers, and therefore also the division of hypercomplex and metacomplex numbers, is undefined. That will be all for now. In the description of this video you can find a link to the article I wrote on division by zero. Please leave your remarks in the comment section below. Thank you for watching.